Hey guys, today we're doing Chapter 4, Section 5, which is on exact values of sine, cosines, and tangent functions. So the first thing I want to do is just a little warm-up to remind us of our special right triangles, because I'm going to actually be going through the unit circle, and I'm going to be using these special right triangles to come up with sine, cosine, and tangent for our unit circle. So we have our 30, 60, 90 here, and if you remember, a 30, 60, 90 is basically just half of an equilateral triangle. So, if this was an equilateral triangle, my side lengths would be 2, 2, and 2. But since I don't have an equilateral triangle, to find this side length, this would just be half of my side length here. So, we'll call that 1. Okay, so half of this side would be 1. And then, to get my other side, I can just use the Pythagorean theorem. So I can say, let's say this is a squared plus 1 squared equals 2 squared. Well, if I solve this, that's a squared plus 1 equals 4. And I subtract 1, that gives me a squared equals 3. So a equals the square root of 3. So this side here is the square root of 3. And this ratio holds true for all of your 30, 60, 90 triangles. Alright, our next one is our 45, 45, 90. Okay, if you remember correctly, we just know that these two sides are the same. So using the Pythagorean theorem, I can say x squared plus x squared equals 2 squared. So that would be 2x squared equals 4. If I divide by 2, I get x squared equals 2. Then I take the square root of both sides and I get x equals the square root of 2. So each of these sides are just the square root of 2. And again, that holds true for all of your 45, 45, 90 triangles. So these should be automatic. You should be able to take these triangles. You should know 45, 45, 90 is always square root 2, square root 2, 2. You should know 30, 60, 90 is across from the 60 is square root 3, across from the 30 is 1, and the hypotenuse is 2. You should always, always, always know that. Okay, you should be able to do those off the top of your head no matter what. And the reason I say that is because you're going to have to be able to come up with all of these measures on the unit circle with no prior knowledge. Okay, this is the only prior knowledge that you need in order to come up with those things. So for most values of theta, the values of sine, cosine, and tangent are not known exactly, but they must be approximated. And that's where our calculator comes in. But for certain theta, we can find exact values of cosine theta, sine theta, and tangent theta. And these are at 30, 45, 60, and multiples of these values. So what we're going to do is we're going to complete the unit circle by calculating the coordinates, which remember are in the form cosine theta, comma sine theta, and we're going to calculate the tangents with exact values. So, starting in my first quadrant here, I know that this point is 1, 0. I know that this point here is 0, 1. I know that this point here is negative 1, 0. And I know that this point down here is 0, negative 1. Those are just points that I know because this is the unit circle, which has a radius of 1. Okay, now I'm going to think about what if I created some sort of triangle here. So if I created a triangle, this triangle would be a, oops, this is a 30-degree angle, this is my 90, so this is my 60. So this is a 30, 60, 90. Now, knowing that, I know that this side is x, so it corresponds to the cosine. I know that this side is y, so it corresponds to the sine, right? So the cosine of 30 and the sine of 30 are what I'm looking at here. Now, knowing my triangle, I know that this would be like 2 square root 3, 1. But the problem is, of course, that this is a radius. So this is actually a side length of 1. So what I can do is I can go through and I can divide these by a half. Or I can divide them by 2, I'm sorry. So I can take half of each of these. So my cosine would be square root 3 over 2. And my sine would be 1 over 2. Another way to think about it is using SOHCAHTOA. So if I want to use SOHCAHTOA and I want to find the, let's just say the cosine of 30, well, remember that cosine is adjacent over hypotenuse. So adjacent, which is square root 3, over the hypotenuse, which is 2, gives you square root 3 over 2. And sine is the opposite over the hypotenuse. So the opposite over the hypotenuse is the 1 over 2. Okay, and then I can also use that to come up with my tangent values. So my tangent is opposite over adjacent. So my opposite right here is 1, and my adjacent is square root 3. So the tangent of 30 degrees is going to be 1 over square root 3. But of course, I have to change that because right now square root 3 is in my denominator, which is not appropriate. So I have to rationalize that. So I have 1 over square root 3 times square root 3 over square root 3. That gives me square root 3 over 3. So my tangent of 30 degrees is square root 3 over 3. Alright, next up I'm going to do my 60-degree angle. So I erased what I had here just because I didn't want my picture to be super messy. I'm sorry, this is going to be my 45-degree angle. So I'm going to draw my triangle here, and this is a 45. That means this is also a 45 because this is a 90. So I've got my 45, 45, 90 here. And remember that this side length is 1 because I have my unit circle, but I'm just going to write it as 2 square root 2, just so I can remember that those are the proportions of my 45, 45, 90 triangle. So, think about that. Remember, my x value stands for my cosine, my y value stands for my sine. So this is my cosine, this is my sine. So my cosine is going to be square root 2 over 2 because it's adjacent over hypotenuse. So square root 2 over 2. My sine is square root 2 over 2 as well because it's the opposite over hypotenuse. And then for my tangent, remember my tangent is sine over cosine. So if I take square root 2 over 2 divided by square root 2 over 2, that just gives me 1. So the tangent of 45 is 1. Okay, now I'm going to go ahead and erase my picture again so that I don't make it super messy here. I'm going to keep my points. So the next one I'm going to do is my 60. When I draw that in, this is my 60 degree, this is my 30. So again, I've got 2 square root 3 and 1 for my triangle here. But remember that this actual length here is 1. Okay, so for my point, I'm going to do my cosine comma my sine. So my cosine, that's my adjacent over hypotenuse, so that's going to be 1 over 2. My sine is my opposite over hypotenuse, so that would be square root 3 over 2. Okay, so then my tangent, remember my tangent is opposite over adjacent, so square root 3 over 1. So the tangent of 60 degrees is square root 3. Okay, then when I look at this point here, my cosine is 1, my sine is 0, and my tangent of 0 would be sine over cosine, which would be 0. Up here, my tangent of this would be 90 degrees. The tangent of 90 degrees is going to be 1 divided by 0, which is undefined. Okay, then, after I found all that stuff in the first quadrant, finding everything else is super easy because it's just the same stuff over and over again. The only difference is that, remember, in the first quadrant, my x values are positive and my y values are positive. So that means that my cosines are positive and my sines are positive. Whereas in my second quadrant, my x values are negative, which means that my cosine values are going to be negative now. And my sine values are going to stay positive. Okay, so that's going to change with each quadrant. Also, when you're thinking about your reference angles here, this angle here would be like my 60. Okay, this angle here would be like my 45. And then this angle here would be like my 30. Okay, so that means that since this is my 60, it would correspond with this point here, except my x values are negative. So this would be negative 1/2 square root of 3 over 2. Okay, this one would be negative square root 2 over 2, square root 2 over 2. And this one would be negative square root 3 over 2, 1/2. Okay, again, the tangents are going to be the same as those other ones. It's just that now they're going to be negative because I have positive divided by a negative for my tangent. So for this one, my tangent is going to be square root 3. For this one, my tangent is going to be 1, or sorry, negative square root 3 and negative 1. And for this one, my tangent is going to be negative square root 3 over 3. Okay, and then I can just do that to fill in the rest of the circle. So, filling in the rest of the circle here, this, my tangent value is going to be 0. 0 divided by negative 1. Down here, this is my 30-degree angle. So my 30 degree, that's like this one here. So that's going to be negative square root 3 over 2, negative 1/2, because in the third quadrant, both of my values are negative. Okay, this one is going to be negative square root 2 over 2, negative square root 2 over 2. So again, they're both negative. And then this one down here is going to be negative 1/2, negative square root 3 over 2. And then again, my tangent values are going to correspond. So this one is going to be positive square root 3 over 3. This one is going to be positive 1. And this one is going to be square root 3. And I can do the same thing over here. So this one, in the fourth quadrant, my y values are negative and my x values are positive. So I will have 1/2 negative square root 3 over 2, square root 2 over 2, negative square root 2 over 2, and square root 3 over 2, negative 1/2. Okay, and this one is going to be a negative tangent, so this will be negative square root 3 over 3, this will be negative 1, and this will be negative square root 3. And this one down here will be undefined because I can't divide by 0. So I've just filled out my unit circle entirely based on just knowing my 30, 60, 90, my 45, 45, 90, my SOHCAHTOA, and also knowing what quadrants give you positive and negative sine and cosine values. So that's all I need to fill out all these exact values for the unit circle. And that's everything for section 5.